Okay, good evening, everyone. This is 8:35. We are 3 minutes, 5 minutes behind rather. In yesterday's class, I introduced you to Aspen Hysys. What Aspen Hysys is, what it's used for. I also um, introduce you guys to the different um, thermodynamic properties and fluid packages in Aspen Hysys when you need to use a specific fluid package. And I also mentioned it that the fluid package you choose affects your simulation. So when you are running a simulation with Ben Robinson, and when you are running that simulation with, let's say, Uniquark or Wilson or NRTL, your results are not going to be the same. Same thing applies if you run your simulation with Ben Robinson and you run it with SRK. There's going to be slight difference in your answer. I introduced you to the working environment where how to add components to Aspen Hysys, how to select fluid package, your simulation window, the message, the message box, which houses your errors and gives other information that has to do with your simulation. So in today's class, we are going to dive into Aspen Hysys, but we are not going to, we are going to start with basic simulation. So please, if you are online at this point in time, I would like you to drop I would like to say something on the chat box. Type I am online so that I know those who are online at this point in time. So if you are not online, just type on the chat box that I'm online. So for those of you that are just joining to this class, for you to be able to type in the comment section, you need to subscribe to the channel. So only who are active subscribers, those are the persons that can comment. The reason we restricted it because this this class is public, so anybody that is going through our YouTube channel can access this class. So, but we don't want any random person to come into the chat box and start saying nonsense. There was a time we had a class and someone started posting a lot of links. So we restricted it if you are participating in this class. And I think I informed the president prior to this time. So you need to make sure you're a subscriber for you to get access to the chat box, okay? One person is online. So please, if you're online, drop a message on the chat box, you are online. Okay, so I believe you all can see my screen, yes? I have here a simple simulation, the very basic step. So this is where we are going to start with. I'm also going to run through things we did yesterday. So we have here our first simulation. We are carrying out this simulation using a mixer, and we are blending two water stream. So imagine you have two pipes that you have two pipes, and pipe A is having hot water, pipe B is having cold water, and you want to mix these two streams. this hot and cold together in order for you to get one stream of output. That's one pipe. So there's a mixer. Or just also imagine you have a tank and you are putting a hot stream and also a cold stream inside that tank so that the both of them will mix inside the tank. Then you open the outlet of the tank, you take your water. You can imagine it, you can picture something like that. So in this case, we have two streams, stream A, stream 1, and stream 2. Now, we are asked to determine the temperature of the outstream. Basically, if we're doing this, calculation, we need to start doing a lot of calculation, but with Aspen Hysys, it's basically straightforward. We know our component, which is water. We have also been given the thermodynamic property here, the mass flow rate, the temperature. We are not given pressure, so I'm going to assume that the pressure we are using is atmospheric pressure. So it's going to be 1 atm. Okay. And yeah, then we run our simulation. Okay. At this point in time, I'm going to share my Aspen Hysys screen. So we are starting with basic examples. So here is my Aspen Hysys screen, which I explained. In order for you to get here, you click on File, click on New, and click on Case to start a new case. But I've already done that. Now, when you open a new case, this is what you are going to see. So also in the comment section, I want to know how many of you have Aspen Hysys installed. How many of you have Aspen Hysys? So if you don't have Aspen Hysys, please drop on the comment section, I don't have Aspen Hysys installed. So basically, maybe depending on how many persons that indicates, I might give few persons the software. Okay, so in the comment section, I want to know if you have Aspen Hysys or not. So here we have the component list by my left right corner. You can see property, just follow my cursor. You can see property, under property you have different items. You have the component list where you pick or select the component you want to work with. For our example, we are working with water. We're going to click on add and type water here. You can type water or you can type H2O. Yes, this added. So you can either use the formula or use the name. Click on water, it has been added. Then I'll click on fluid package, select the fluid package I want to work with. Scroll down. For this, I might, okay, let's assume I don't know the fluid package to use. I'm going to click on method assistant and okay, this is not a gas processing operation. Okay, let me see if I type water here. I'm going to see a result. Okay, we have free water, specifying free water, dirty water calculation, troubleshooting. Let's click on free water. So free water calculation involves moon. Okay, so I'm trying to see if I can use So sorry for that break in transmission. So I want to, okay, I believe you all can see my screen. Okay, somebody said he thought this feature is the paid. No, I mentioned it in a previous class that method assistant is available for everyone if you want to know the particular method you want to use. So for this, I'm going to close this. I gave a simple summary of the different method assistants to use from our previous class yesterday, which I'm going to share. Just give me a minute. Let me share my slide. Uh, okay, which is from equation of states. So I believe you all can see my screen or see my slide. So for general methods, we have ID property package, which is used for ideal gases and ideal liquid behavior. So for this, we can classify um, water as an ideal liquid behavior, or we come down um, to the summary where I said polar and isotropic system, which we have ethanol water, acetone water. So in this case, when you have something that has to do with water, you use NRTL, Uniquark, or Wilson. Okay. I'm trying to link what we have learned yesterday to what we are doing today. So water is a polar molecule, not non-polar. So if we are simulating a polar system, we need to go with what either NRTL, Uniquark, or Wilson. So let's go back to where Uniquark said this handles. Okay, NRTL, he said is good for polar mixtures and solvents. We also know that water is a universal solvent. So from this, we have three options. NRT, Uniquark, and Wilson. So these three now, we are going to go with NRTL because it's best match the components we are working with. I believe that's clear. So if you have any question with regards to this, please drop it in the comment section. Yeah, somebody said it is similar to DWSIM. Yeah, DWSIM is an open source software, but I haven't really used it before in depth, so I don't know how advanced it is. But as Hysys is actually good. So if you also have DWSIM, you can also use that, provided you know how to um, go through all the stuff. So we are going with NRTL, which is this NRTL. Yeah. Then switch over to my simulation environment. Okay. From our example, we have two um, streams. So what I'm going to do, I'll click on material stream, drop, click on it again, and drop. So we have two streams now. I'll double click on stream one, which you can see stream name one. Click once and name this stream one. Temperature. For this, temperature is 30 degrees and mass flow rate is 5 kilograms per second. So we have 30 degrees 30 degrees. We have different, um, we have Celsius, we have Kelvin, we have Fahrenheit. You can pick from any of these temperature units. So for this, it was given in Celsius. So if the project you're working with is given in Fahrenheit or Kelvin, you select any of this. I'm going to click on Celsius. Now, if you hover over that, you are going to see Hysys is going to give you that what you have gotten in another. So you can see 30 degrees Celsius. You can also see it's going to convert it to Fahrenheit. You can also see 68, 68 Fahrenheit. Then our mass flow, which is our mass flow is 5. Our mass flow is 5. I'm going to type 5. Come down here to kilogram per second. That's what we are giving. Then pressure, like I said, we are going to use 1 atm, 1 atmospheric pressure. Okay. I'll delete all this and start all over again because I want to. Okay, so when you open a stream like this, there is a warning signal at the bottom. It says unknown composition. So it's more like it's telling you some of the parameters you haven't specified yet. Now, I can decide to follow it straightforward or follow the warning at the bottom. So when it shows yellow, it means there are things you need to specify. When it's showing red, it means you haven't specified anything at all. So I'm going to come to position and click on edit. We have different composition bases. We have mole fraction, mass fraction, mole flow, mass flow, liquid volume. So I'm using mole fraction, which I will type as 1. Click OK. Now you can see it has changed to unknown temperature. For this, I'm going to come back to conditions and temperature. I will use 30, which is what was given in centigrade. Pressure, say unknown pressure, I'm going to use 1 bar, 1 atm rather. Then it says unknown flow, which is mass flow, 5 kilogram per second. Okay, you can see that. Okay, so you can see that it has changed to green. When it shows green, it means you have specified the required, you have given Fahrenheit the minimum information. You have given Fahrenheit the minimum information it needs for it to carry out its simulation. Okay, I'm going to close this. Now you can see that there's a difference between these two streams, stream 1 and 2. Stream 2 is showing light blue. That's because I haven't specified, I haven't given Hysys the required information for this stream. And it's not yet specified. So I'm going to double click on it. Click here and type stream 2. The temperature I'm going to use for stream 2 is 80 and 10 kilogram per second. Okay, 80, 80, degrees Celsius and 10 kilogram per second. Then I'll come to composition. I'll come to composition, which what we have is also water. And I'm going to type 1 as the mole fraction. I believe everybody understands what mole fraction. Okay, I haven't specified the pressure. Come to conditions and specify pressure 1 bar, 1 atm rather. Now this stream has been specified. Now you can see that it has changed to blue. Okay, I can okay. So in order for me to be able to mix these two streams, I need to use a mixer. And we know that a mixer is a unit operation. Yeah. So I'm going to come to inlet. You can see inlet here. Specify stream 1, specify stream 2. Then I will type mixed out. Mixed out. Okay. You can now see that it has showed me green. Okay. Which means it has been fully what specified. Our question says we should determine the temperature of the output stream, of the mixed stream. So I can double click here, then come here. I'm going to see the temperature here, which is 63.28 degrees Celsius or 145.9 Fahrenheit. Hysys has calculated the temperature, it has also calculated the pressure. So there was a slight increase of pressure. The increase is 0.13. It has also calculated the flow rate, the mass flow. We also have the molar flow as this. So every other calculation that has to do with the output stream, Hysys calculated it for us. So I believe this is well understood. So in order for us to get a better understanding of this, I'll click on workbook. Okay. Now, when I click on workbook, Hysys is going to show me all the material streams. So this is also used in getting your heat and material balance. Yes. So where I am now, I'm just in my material stream. So you can see in my material stream, I have water. I can see the temperature 30. For stream 2, I can see 80 mixed out, which is what Hysys calculated, 63.2. For this, okay, 1 bar, 1 atm, which is 1.013 bar. The same thing. So our pressure was constant. Molar flow. For stream 1, we had a molar flow of. Okay, and some other thing I want you to know, the letters or texts that are on blue are things you can change from or you can edit from your end. So stream 1, I can always change stream 1 from stream 1 to, I can always change that. You get, but you can't change the vapor fraction. Whatever is in solid black, black, any text in black, those parameters were calculated by Aspen Hysys. You can't alter it. The only things you can change are text that are on blue. Okay. So the mass flow Aspen Hysys has also calculated it and given us that for. And also giving us that for our mixed out. So if you have a question, please drop it. I have around me. Okay. Um, give me a minute. Let me check the chat box if there is a question. Okay. Please, if you have question, drop it in the chat box. Okay. The next question or example we are going to take. So we are also going to look at heater. We are going to look at pump. We are going to look at heater. We are going to look at pump and splitter also. Now we use the mixer. We can also use a splitter to divide certain flow into different portions. So for this example, we are simply going to use a splitter. We'll continue with the current example we have. So for this, we say water stream 100 kilogram per hour at this temperature is split into two equal parts. Verify that the outlet stream have the same property as the inlet stream. Okay, let's see. Then the split ratio, this is what we are interested in, the split ratio. Let's switch back to Aspen Hysys. Okay, so for this, I'm going to click, I'm going to select a splitter. This is our splitter. I'll double click on our splitter. Now you can see that this splitter is showing red. It has a red icon. So it means we haven't specified anything on it. So for this, we need to specify the input stream. The input stream is mixed out. We also need to specify the product stream. I'm going to specify as split one. I'm going to specify this as split one. Now, you find out that the moment I specify this, everything turns to blue, which means everything is fully specified. But our information says the example we are working with says there are two splits or two streams. So I'm going to double click on this again. Go to parameters. Okay. Go to connection and specify split two. Split two. Hit enter. The moment I do that, I get an error message which says unknown split, unknown split. So I'm going to come to parameters and specify the flow rate, the flow ratios rather. And in order for me to specify this area, I have just 1 degree of freedom, meaning I can only specify one. So if I'm to share an orange between two persons, and I have two persons, A and B. I said I'm going to give A half of the orange. It automatically means B is getting half, isn't it? But if I say, if there are three persons I'm going to share this orange with, and I said I'm going to give A half, it means B and C is going to share this other half. But the ratio at which I'm going to share it between B and C, that's what we don't know. I might share it equally, 50-50. That half now will be divided into two. C is going to take half, D is going to take half. I might say no, that B is going to take 60% of that half, while C is going to take 40%. So at that point in time, if I have three parameters to fill, the degree of freedom is always M minus 1. So the three parameters I'm going to specify minus 1. So in this case, we have just two parameters. So it's what M minus 1, which is 1. So I have 1 degree of freedom. Now, question says 50-50, which is 50%, 50%. More ratio is 0.5. So when I specify for split 1, you can see that our spend height is automatically calculates for split 2. And like I said in the previous example, any text that is labeled with blue is what you can manipulate. The one that is in black, as when Hysys did the calculation. So if I change this to 0.6, enter, you can see that as when Hysys calculated the other splits to be 0.4. If I specify this to be 0.4, as when Hysys is going to calculate the other one to be 0.4. But our example says 50-50, which is 50%. Then I'll close this. So you can see that I've successfully calculated this. So I want to know the composition of this. I click on my workbook again. We have split 1 and we also have split 2. Split 2, temperature is 36, 63 rather, 63, the same thing. Okay, we have molar flow, the same thing. So basically the same thing because it was split 50-50. Then I can also come to compositions and see the mole fraction of water here is 1, mole fraction of water here is 1, which means we are correct. But whatever we did, we are absolutely correct. But if we change this parameter to 60% goes to stream 1 or split 1, go back to my workbook. Now you can see the mole fraction for decide to use this as horizontal. Okay, for split 1, I can see the mole fraction is the molar flow is 1,798 molar flow for split 1. For split two, it is 1,199. It's changed. Okay. For this, we can do some other manipulation. Please, if you have a question, feel free to ask. Okay, somebody said the useful takeaway is the fact that the parameters in black were calculated by analysis and cannot be altered, unlike those in blue. Yeah, correct. I have a question. This software, as I said, is very much similar to this. And okay, the question you asked, I haven't used this software to a great level, but um, AWSIM is an open source software, so it means you don't need a licensing for it. The interface of DWSIM and Aspen are totally different. Since it's an open source software, there are limitations to it. You understand? Aspen, apart from using Aspen Hysys, there's another software called Aspen Plus. So now, when you are using Aspen Plus and Aspen Hysys, these are two softwares I am a professional at using. So I can talk about them extensively. Aspen Plus has more database. It can carry out more complex simulation than Aspen Hysys. Aspen Hysys, its strength is in the oil and gas, refinery, oil and gas processing, LNG, carrying out those kind of simulation. Aspen Hysys is good. But if you want to carry out something more complex, in terms of getting better equipment sizing, and you want to go into something like pharmaceutical, um, um, some other simulation apart from oil and gas, you can use Aspen Plus. Aspen Plus is perfect, better, because it can do more rigorous simulation than Hysys. You get. So if you want to bring DWSIM into this equation, and most companies, I haven't seen an oil and gas company that is using DWSIM. So it means that DWSIM cannot carry out some simulation that Aspen Hysys can carry out. Or if it does that, the accuracy is not going to be like Hysys. So imagine if Schlumberger is using Hysys, Chevron is giving you a project and they are coming for audit. They are like, do you have Aspen Hysys? Are you using the paid version? You get. So if they are not talking about DWSIM, it means it is not what industry standard. It's not recognized in the industry. It is just being used for practice most of the time. So as an upcoming process engineer, you can use DWSIM to start your walkway, since it's difficult for you to get lay hands on Aspen Hysys. Okay, yeah, I think I answered the question. So yeah, I need more questions like this. So it means it's only Percy Speaks and Jessica and Chooks that have been attending this class. Currently, I think we have 5 views. Out of 5, there's only one person that is active. So please, if you are, I don't even know how to get this person's contact now. Percy Speaks, because you have been one of the most active persons in yesterday's class and today's class. Okay, if you are online, please indicate in the comment section. Now we have 4 persons. Let's take another example. So in this example, we are going to use pump. We are going to use pump. What does a pump do? First of all, before we start talking about layman understanding, tell me what a pump does. I'm still waiting for your feedback. What's the function of a pump? Is basically used in increasing pressure. So if you want to move a fluid, and pumps are used for fluid, sometimes semi-solid. You can see something like semi-solid in or molten form. You can use pump in pumping out mud. You can use pump in dredging. Whenever they are dredging sand, they use pump. So, and when you are dredging sand, what you are pumping out is both sand and liquid water. Okay, so pump is basically used in increasing the pressure. You understand? And you can see that in car wash. You want to pump water and fill your tank. You use pump in doing that, which is the function of this sumo, as they call it. So I'm just trying to use basic example. So for this, a pump is used in increasing the pressure of water from 1 atm to 5 atm. The inlet of is this, the flow rate is this. Determine the work required by the pump. Determine the work required by the pump. So I'm going to go back to the simulation we have been doing. And for this, I will delete stream. Okay, I'm going to delete this stream. Okay, then from here, I'll introduce my pump. I'll come to my model palette. I can type pump here, click on it. Then click on this stream and name this pump out. Pump out, close. Then double click on my pump, specify the inlet, which is mixed out, specify the outlet, which is pump out. Now this, I need an energy stream. Definitely, our pump needs energy, it needs power. It needs to, it's being powered by something. So I'm going to specify our energy stream as PQ. Now, after that, it says what? Unknown duty. Unknown duty. You can see that our pump is no longer in red color, it's now in yellow. Yeah, yellow color. Now, when it's showing you in yellow, it means that particular equipment have not been solved. There are still things you need to do or specify. So what do we need to specify? There is a change in pressure, isn't it? From our example, we were told that this pump changes the pressure um, from 1 bar, sorry, from 1 atm, 5 atm. So what we need to do now is to come down to, I'm going to double click on this pump out and specify the pressure. the output pressure, and which is 5 atm. So the moment I specify it, Aspen Hysys automatically calculates the change in pressure of the pump and calculates the duty. That means the energy required to drive that pump to give us that change. I don't know if you understand it. You are getting what we are saying, because this is now chemical engineering. We are basically doing your car, or yeah, your pump. You understand? The pump changes pressure from low pressure to high pressure. And our example says that it changed the pressure from 1 atm, as you can see here, to 5 atm, isn't it? Now, if we have successfully changed this pressure, what is the amount of work done by this pump to change the pressure? You understand? So the pump you are going to use in doing sumo is not the same pump you are going to use if you want to transfer fluid from Imo State to Lagos State. You are definitely not going to use the same pump. You get? Because one has more power. One requires more power. The same thing if you are dredging. The pump you are going to use for your sumo, or the pump used in washing car, it's not the same pump you are going to use to pump your water. And sumo also have different what sizes, different sizes. Calibration. Depending on the height that sumo is required to pump that water to. Okay, yeah. So I believe I've explained that a lot. For this, I will double click on my pump, come to parameters. So for this now, under my parameters, you can see what my delta P is 4.053 bar. And how do we calculate pressure change? Change is final minus initial. So if you have a final at 5 and our initial is what? 1, 5 minus 1 is 4. But due to the efficiency of this pump, the efficiency of this pump is what? 75%. The pressure ratio is 5. Now, this is the duty, this is the work, the power required to drive this pump. We have 8.290 kilowatts. That's the power needed to drive the pump in order for us to get this change. And you can see that it is what in the text is in black. It means it was calculated by Aspen Hysys. So there's something else I'm going to do. Okay, so for this, you can see the temperature. The temperature here is 63.33. So initially, in mixed out, the temperature here was 63.28. But when it came out, there was an increase in temperature. Why is there an increase in temperature? Normally, the moment you exert pressure, temperature increases. That's basic thermodynamics, conversion of energy. The moment you increase pressure, there's an increase in temperature. So this is mixed out. Mixed out was coming in at this. There was a slight increase in temperature. Pressure 1 bar, but when it came out 5 bar. Molar flow, the same thing. Okay, this is what at Um, this is at 75% efficiency. I'm going to click on this, come to parameters, and change this to 50% efficiency. Now, at 50% efficiency, for this same pump to carry out the required function, due to the power needed has increased to what? 12.4346 kilowatts. You see, so the efficiency of that pump is directly proportional to the power needed to drive the pump. If I close this, you can see that the temperature has also increased again. There's more increase in temperature. Now this is 3.39. If this pump was running at 90, this pump is 90% efficient. The power required has reduced, and the power is now at 6.9. Let us look at the temperature change. Temperature change has dropped a little bit compared to previously. This is 63.31. So I believe you all are understanding what I'm doing here. Then I'm going to add this to my splitter, pump out. It has successfully calculated everything. Okay. So gradually, you guys are understanding Aspen Hysys and relating it to chemical engineering. If you have a question, please ask. Okay. So I'm going to take one other example. Something a little bit more complex, which is this, where you have your separator, you have mixer, you have your feed, you have behind separator a very long time in chemical engineering. So this is the time required. I'm just checking for some other examples that I can use. Um, okay, so we are going to go with this example. We have the components here, methane, ethane, propane, n-butane, I-butane, 1,3-butadiene, and we have the mass flow here. The equation of state we are using is SRK, equation of state. We have your feed, pump, in this we have your recycle stream. Currently, I'm not sharing my simulation screen. I think I am oh yeah, I'm sharing a slide. I'm sharing a slide. Yeah, for those of you online also, I would like you to like this session. Okay, so we have this. This is what we are going to celebrate now. Let's jump into Aspen Hysys. So you can screenshot this and send it to your colleague. For those of them that missed, these are things we did. Okay, so I'm going to create a new document, sorry, a new flow sheet or simulation case. Just give Aspen a little time, it's loading. Okay, um, someone said it wasn't showing you explaining the form. Okay, you can also always go back and watch the videos again. The videos is on our YouTube channel. So the same link you clicked to participate in this class, go back. Um, I just went through, I checked the video, I explained it and it showed. Maybe it was from your end, network or something. Okay, so for this, we need to impute components, and we have methane, ethane, propane, and butane. Methane, ethane, propane, and butane, right? Yeah. Then you also have one butane. So I'm going to type butane, one butane here. Add. We also have 1,3-butadiene. I can look for butadiene. Butadiene. Okay. I can't say it's 1,3. One three butadiene. Okay, look at it here. 1,3-butadiene. Add. Yeah. click on this, and our fluid package is SRK. Select SRK. That's the first step. The next step is to specify the feed. That feed you have been hearing every time in separation process. Feed, assume feed. Then the next thing I'm going to do is to come to my composition, click on edit, and start specifying this composition. I'm using mass flow, or the example is the mass flow. So I'm going to click on mass flow here. This is mass flow. Yeah, so you can see component mass flow, which is 50, 100, 700. So I'm going to type 50 here, 100 here. And the flow rate is what? Pounds per hour. So this is 50 pounds per hour. This is 100 pounds per hour. This is 700 and 870. 700. 870 pounds per hour. Then we have 11765130. 1176 1176. Yeah, 5130 pounds per hour. Click on OK. Then go over to condition, set the temperature. Temperature is 85 degrees Celsius and pressure is 100 psia. 80 degrees Celsius, 80 degrees Celsius and 100 psia. Click on it. And our feed has been set. Okay, from this, we need to add a mixer. We need to add a mixer. And this is our mixer here. And we have another stream. Double click. I'm going to name this mixer. Mixer. Name this mix feed. Name this mixed feed and close this. Double click on my mixer. My inlet stream is feed. My outlet stream is mixed feed. Very simple, and I don't have any error in my message dialog box. I don't have any warning, means I'm good to go. So the next thing is to add my two-phase separator. This is my two-phase separator. And I have the top stream and I have the bottom stream. The top stream, I'm going to name it vapor. The bottom stream, I'm going to name it liquid. I'll double click on this and I'm going to give it an energy because the reason I'm doing that, I'll share my slides so that you can see what I'm doing. Okay, so for this, you can see that there is a coolant here, and the operating temperature for this separator is 5 degrees. So it means the feed is being cooled from 85 to what, 5. So I need to also go back to Hysys and do some changes to some changes to my feed. My feed initially I used 80, supposed to be 85. I need to type 85 here and hit enter. So I'm going to double click this and use SQ as the energy stream. Outlet, I'm going to use liquid. I'm going to use vapor. Here, I'm going to use mixed feed. Now, it says what? Unknown duty. Why is it saying unknown duty? And what are we trying to say? It says, as far as it's saying, with the informations I have, I can't calculate the power this separator is going to use. Remember, we are specified an energy stream or the energy needed by this separator. You can see the energy stream there. So in order for us to be able to calculate that, I can specify just one component, one of the stream. One of this stream is going to be pi. When I hit enter, as Hysys does the entire calculation, it calculates everything. You understand? So after that, there is still some other thing we need to do. A fraction of this bottom needs to be pumped back into the feed as recycle. So it means I have another stream here, which is called bottom products. Bottom products. I'm going to use a splitter here. Now this splitter is going to split this stream. We have another one here to pump. I'm going to name this to pump. Double click. My inlet stream is what? Liquid. My outlet stream bottom. The next one is to pump. So sure. Yes. I didn't know that you guys are not seeing. Sorry. Okay, I'm going to take that. I'm going to take that all over again. Okay, I'm going to take this whole simulation all over again. I didn't know I wasn't sharing my screen, my Hysys screen. So, okay, I think I'm going to delete this separator, delete this mixer. Okay. So I'll click on my two-way separator, select it, double click on it, specify. Okay, let me show. Yeah. Specify my energy stream, SQ. This I'm going to separator. I'm going to click on vapor. I'm going to click on liquid. Then mixed, feed mix. You can see that has been calculated. Okay, the reason it's calculating normally is not supposed to do that. I'm going to delete this. Yeah, This is what it's supposed to show me, that this is not calculated. But from our example, the example we are working with, the operating temperature of this separator um, is 5 degrees centigrade. Centigrade. So if the water in a kettle is 100 degrees centigrade, if you turn that water out into a cup and test it immediately, it's supposed to give you 100 degrees, isn't it? Or you put a thermometer inside, it's going to give you 100 degrees. So what I need to do is, I need to just specify one of the stream. I need to tell Aspenalysis either the liquid stream or the vapor stream, whichever one. I'm going to tell Aspenalysis the output temperature, which is 5 degrees centigrade. The moment I click on it and hit enter, Aspenalysis automatically calculates the other properties, and also carries out the simulation. I don't have, there's no error here. I'm going to use a splitter, put a splitter here. And I have two streams, which you already know how to select the stream. So for this, I'm going to select the T, select the input stream, which is liquid, select the output, which is bottom product, which is what we have here. You can see it, this. We also have our pump out, to pump rather. Now, the moment I do that, Aspenalysis no longer calculates this again, because it does not know the split fraction of this. Now, for this, the split fraction is 60% is going to the bottom product, while 40% is going back to the mixer. So I'm going to come here, bottom product 0.6 more percent, more ratio rather. So you can see that this has been calculated. I'm going to add my pump here. Yeah, I have my pump here. And I have another stream here. I'm going to call it recycle. Recycle. I'll double click on this. My inlet stream is to pump. My outlet stream is recycle. So this is what we have. Stand. Okay, and this pump, want to feed this back to the mixer. So I'm coming, let me check my example if I have the okay, so for this, I don't have the operating conditions of this pump. So, but what I'm going to do, the pressure here is 6.8 bar or 6.9. The pressure in the feed is what? The pressure in the feed is also 6.8 bar. Okay, the pressure here is also 6.8 bar. So what we want to do is I'm going to specify the pressure, which is 6.89 bar. Okay, it says unknown temperature. I'm going to still use 5 degrees Celsius, and that's calculated it. Double click on it. It says it requires an energy stream. So I'm going to use PQ. Let's enter. It says pump has negative head. Okay, so what I'm going to do now is this recycle, I'm going to increase the pressure here to 10. So it has been calculated. This recycle needs to go back to this mixer. So I'm going to click on mixer, click here, and add recycle. The moment I do this, it's going to tell me not solved because you don't calculate a recycle stream like this in Aspen Hysys. So I'm going to delete this. So before you calculate your recycle stream, you need to come to manipulators and click on recycle. Double click the recycle, select the input stream, recycle, and use this as the feed. Hit enter. It calculates it. So what we are now going to send to our mixer is this to feed. And the moment we do that, you can see that everything has been what? Calculated. We don't have any error whatsoever in this simulation. So from this, we can show table and see our bottom product. Come here, show table and see our top product. So it seems like most of what we got, we have more of the substance coming out from the bottom. Because remember, it was cooled from 85 to 5. And we have what the bottom product. Okay, so that's that for, I'm going to take more questions. So how many of you followed us up to the end of today's class? Ah. The participation of this class is actually low. I know some of the things you guys have been told is go and read book, go and read book, go and read book. See, in the industry, in this currently we have just two persons that are live, just two persons. The maximum number we have today is 7. And this is something that is required in the industry, oh, because definitely there's no company that will employ you because you just finished chemical engineering. You have to go through training process. And this is one of the requirements, core requirement that is needed in the industry. And although Chooks, we still need to talk on how, because this turn up is not something I'm going to take my time. This live stream has lasted for about 1 hour, 30 minutes, and just 7 persons participated. That's the highest. So currently, we just have only 2 persons active. So um, we need to talk, and this is something that needs to be preached to chemical engineering students constantly. You need to learn how to use Hysys. You need to learn how to use AutoCAD. These are the two important things you need to learn how to use. As the fact that you want to work in the oil and gas sector, you can't run away from these two things. You can't run away from developing a BFD, which is block flow diagram. You can't run away from developing a PFD, piping and instrumentation diagram. You can't run away from developing a PID. Sorry, yeah, P and ID, that's piping, PFD, process flow diagram. What you are just seeing on the screen, this is a PFD, process flow diagram. You know, for those of you now that are in 500 level, when we did plant design, you could see all those material stream, all those stuff they did, blah blah. This is basically it. This is basically what we are doing now. This is basically it. You understand? This is a simple PFD. From this now, you can get your heat and material balance. From this, you can now size this separator because all you just have is the operating condition, which is operating condition of this now. Let me show table. Our separator, 5 degrees, 5 bar, low rate duty. This is it. Minus because it's removing heat. But we can't size it. We don't know the height of this separator. We don't know the diameter of this separator. We don't know the internal component of this separator. With asperities, you can still do this. The same thing applies to these lines. These lines you are seeing to pump. This is a liquid line. We don't know the diameter of this pipe. So that's it. You can still do that in Hysys. But this amount of persons I'm seeing, 7 persons, is not what I'm going to stress myself for close to 1 hour, 30 minutes teaching 7 persons. When I believe this publicity was made from 100 level to 500 level. And the 500 level students that are supposed to take this serious are not taking it serious at all. This is why a paid training is good, because if they pay money, even if it's 5,000 to learn this, they will definitely come online and learn it. But since it's free, they don't have anything to lose. But like I said, Chooks, we need to sit down and talk. For those of you that are here, we are going to talk with the president on how we can have a more robust class on Aspen Hysys, but it's going to be at a token. I'm not really charging for it, just for my time, and to make sure that some persons take it serious. This one that we are doing 2018, 2019 set is doing for free. You can see that just participants we have, 7 participants we have, whereas only 500 level, 400 level, we have the talker. Is this Frank Talker or what are they calling this boy? Oracle. Oracle, is this you? Say you have been here all this while. So why didn't my YouTube detect you? Now we are seeing 3 persons online. Okay, anyway, Sha, Chooks, Oracle, we need to talk. So I believe I've done justice to the basic aspect of advanced analysis. All of you that have been participating in this class can carry out a good simulation, but we still need to go deeper. There are other things that you are supposed to know how to do as okay, Oracle is present. The other things you need to know how to do as a process engineer. Let me don't call chemical as a process engineer. There are so many things in Hysys you need to know how to. You need to know how to do. You need to know how to work with petroleum characterization, petroleum product itself, and some other real life simulation. And I'm also going to call some process engineers in the field to take us through on some certain things, basic things rather. Okay, thank you all for participating into this class. Yesterday we spent more than 1 hour 30 minutes. Today, 1 hour 33 minutes. I also appreciate those of you that participated, took your time to participate. You are better than your colleagues that didn't participate at all. So even if you don't have Hysys software, which during the paid training, we are going to look for how to make that available. At least you know how Hysys operates. You know that you can perform a separator, a two-way separation process. You know how pump is being carried out and all of that. Thank you once again. We are going to see some other time. Bye and have a good night, guys.